Okay, so typically what I'll do if I record something, I'll post it at the end of the day. So what you see here, okay, what you see here will be posted after school.
You recording? Oh my God, hey.
Okay. So yesterday we started working with literal equations. Okay, it's a 9th grade topic, but it's very, very similar to solving equations that you've already done. The difference is now you're not just dealing with numbers, now you might be seeing some variables in addition, more variables. Okay, so here are a few formulas. Now, you've worked with formulas before. The perimeter of a rectangle, for example, you may not have worked with it as a formula. Maybe you just say, well, I add up all the sides of the rectangle, which is true. But the formula for the perimeter would be 2 times the length, 2 of the length, right, plus 2 of the width. That's how we add up all sides. You also have here, these mostly are, except for the temperature, these are formulas you've used, right? You've used circumference of a circle, you've used the area of a rectangle, area of a triangle, area of a circle as well. The distance formula here, you have used. Like last year, if you had a problem such as so-and-so drove 150 miles in 3 hours, what were her miles per hour? That's a distance travel question. Distance equals rate times time. So today, those are literal equations because they have multiple variables in there. We're going to start to solve literal equations for a specific variable. Now, yesterday when we talked about this, we remember, hopefully, that when we say solve, we're not looking for a number. The idea of solving an equation, what we've been doing is isolating a variable. So if there's a whole bunch of stuff going on here, we can still isolate something. Okay, so we're going to start with one of these formulas as an example. In this scenario, which
I wanted to get the area of the circle, because that's on iReady all the time.
okay, area of the circle, pi r squared,
Area of the circle.
pi times radius squared. Yeah.
Oh, never mind.
Okay, so here's the one. We're going to start with this. Okay, in this scenario, what is the radius of a circle with a circumference of 64 feet? What formula are we dealing with here? Now, I'm not concerned with what the radius is. We're using this problem to generate the understanding of literal equations. What is the formula that you think we should use right now? Think about the information that's in here.
The circle.
What about the circle? The circumference. They specifically tell us here that they're giving us the circumference. So that's probably going to be the formula we want to use. Right? Who remembers from maybe the previous slide or when you learned it before, the circumference of a circle?
C equals 2.
There's the circumference is 2 times
Pi.
pi times the radius. Absolutely. So this is the formula. Okay? What is the circumference? Who remembers what that is?
The round part.
Yeah, it's the outside. Right? So I always like to explain it as like the perimeter of my circle. It's the measurement all the way around. Okay, so we're going to use this formula. What variable do we want to solve for? Look at the question. What are we trying to find? The question tells us we're trying to find the radius. So I need to figure out how to get that by itself. And we talked yesterday about why we do that. Why did we want to isolate the variable? Think about when you substituted values in yesterday, what was happening? When was it easiest? Yeah, like the simplified one, where the variable that we wanted alone was actually alone. Right? So we want to get r by itself. What's happening to the radius right now? It's being multiplied by what? By 2 and by pi. So when we solve an equation, whether it's with a variable or just an integer, how do we solve? What do we do? If we know that something's happening, we undo, right? So if we know that the radius is multiplying by 2 and by pi, what do you think I'm going to want to do to get the radius alone?
Divide by pi.
Divide by 2 and divide by pi. Absolutely. So if I do that, I'll actually write it over here. Can I divide by 2 and by pi? Can I do this? I can, as long as what?
You do it on the other side.
As long as I do it to the other side. Now again, the goal here is when we talk about solving literal equations, you're not going to get a number as your answer. You're just rewriting your formula to get a certain variable by itself. So now here, my radius is alone. The formula has not changed. I just rewrote it so that my isolated variable is my radius. This is actually how it's shown step by step in your textbook. This is pretty much the entire process for this scenario. The reason we use this, they gave us the circumference. We already know the number 2. We already know the symbol pi. We want to find the radius. That was the question, right? They said if you know that the circumference is 64, what's the radius? So now notice, if I had this here and I substituted in a 64, I could calculate it. Right? It would take me a little bit of calculation, but I could do it. It's so much easier here when you already have your variable isolated. If I do divide 64 by 2 pi, which is about 6.28, my answer here would be about 10.2. The answer itself right now, the 10.2, is not as important because we're focusing on the idea of solving a literal equation and isolating a variable.
Why is the equal sign at the bottom, like the last one?
What do you think the difference is? That's a good question. What do you think the difference is between this symbol and the squiggle?
I don't know why I
Well, someone else might have an idea. Because when I said R is, I said something else. What? Okay.
I think it's rounded.
Rounded? Okay, yeah. That would be like is about, it's an estimate, right? More of an estimate. If I knew it was exactly 10.2, then yes, but when I'm dealing with the number pi, which is irrational, that 10.2, that number could go on forever. So I'm rounding to 10.2. So that would be like a symbol for like an estimate, approximately 10.2. So what did we do? We solved an equation for a specific variable. Typically though, when you have equations like this, you're solving for a specific variable too. You're just solving for x. It's the same thing. The difference is in this scenario, all the operations you're doing have to do with just a number, just an integer. In this scenario with the circumference formula, you're doing operations with variables, but you can still do that. Okay. We're going to go through other examples of this so that you can see what else. We're going to do another example after this one. Anyone need more time, or are we okay?
I need more time.
Okay. This is in the textbook. Typically when you do some of the practice problems that we do in the text, I intentionally use the same problems that are in the textbook so that if it's confusing for you, you can look back. A lot of the practice problems for this are on page like 112. These questions are actually on page like 110, 109. And I copied this. I screenshotted this image where they showed the step-by-step from the text. So you'll have that as a resource. If you need the online access to the textbook, you can get it in the Google Classroom. You can look at these at home. So let's try this one. You're going to find, well, here's our question. What is the height of a triangle that has an area of 24 and a base with a length of 8? So you have to do two things here. First, you need to identify what formula am I using. Then, you want to rewrite the formula to solve for what? What do we want to solve for? What's the question? To solve for the height. So identify the formula first. You can do this together, you don't have to do it alone. What formula do we think we're being asked about? Write that formula down. If you remember, which some of you do, some of you may not, that's fine. Work together with the people around you to figure out what formula it is we should even be using. And then how do I rewrite that to solve for my height?
That's the hard part because I know the answer. I don't know how to.
which formula, think about the information that they're giving you. That might help you figure out which formula.
You learned it in 7th grade, right? 7 or 6.
It's also something have to be expressed.
What formula should we use? Based on the information they gave us, what formula do you think they use? Look at the information in it.
Because it's a square, right? And
What?
then, like, divided by 2 or something.
Right, but what is that? How are we going to determine which formula is used? Or is there something in here that hints to me that a specific formula was used? What information can we pull out and say, that's definitely the formula?
The triangle.
Okay, so we know we're dealing with the triangle because it says that we're dealing with a triangle. What formula about a triangle?
It's
The area. They tell us the area of the triangle. This right here, that's your clue. If they're talking about a triangle and they're giving us the value for the area, think about what they're asking for. They're giving us the area, they're asking about the height, and they're giving us the base. What's the formula for the area of a triangle?
half a square.
That's the base times height.
1/2
Yeah,
times
yeah, that.
base times height. That's the area of the triangle. And notice in this scenario they gave you everything except the height. They asked you about the height. Now, you could just substitute the values in and figure it out, but that's not what our focus is. Our focus is actually rewriting the equation, rewriting the formula to solve for h. What's happening to h?
It's being multiplied by
The B.
It's being multiplied by b, and what else?
half.
It's being multiplied by half. So what do I need to do?
Undo.
I have to undo. And how am I going to undo?
Division.
Divide by?
3/4.
Base.
Divide by the base, and then what?
The half.
And then divide by the half. Do I have to do them at the same time?
No.
No, I don't have to. And as you see some of these complex formulas, you may not want to. You may want to kind of go in stages. So here, if I divide by b, I can rewrite this. That's a big one, so it's gone. Then what can I do to get rid of the 1/2? Dividing by a half is the same as doing what?
Multiply by 2.
Multiplying by 2. That's a big one. So now we have 2a over b. So really all we did, we got h alone. We divided by the b. We did divide by the half, which is the same as multiplying by 2. Now, if I have this formula, and I know that the area is 24 and the base is 8, what would you do with your literal equation to find the height?
Well, do we have to substitute
Yeah, what can you substitute?
the base
Yep.
and the answer?
So I have
Area.
2, I can substitute in the area of 24, and I can substitute in the base, I don't need the parentheses there, of 8. So what is my height?
4 divided by 8.
My height is 6.
Yeah.
Now here I want you to understand that yes, finding the height of 6 was helpful to finish the problem, because that was the question. But the purpose of this lesson is that we're understanding how to rewrite the equation. Okay, to make the connection that even though we're dealing with a lot of crazy variables, you're still solving the exact same way you did when you were looking for an actual answer. Okay. We're going to go through one more example, and then we're going to practice. Because yesterday we didn't really have time to practice, and I said you're going to have plenty of time to practice.
Isn't this practice? Or
It is. It absolutely is. But the practice time I'm talking about is when you can practice with each other. Because what's happening now is, and I noticed it this morning, the groups that are working together are really starting to help each other. And that's when you're going to learn the most, is when you're working on things together. So here is our Last scenario, the monarch butterfly is the only butterfly that migrates annually north and south. I did not know that until reading this. The distance that a particular group of monarch butterflies travels is shown here in the picture. They go from Indiana to Mexico. Who knew?
That's rad.
It takes a typical butterfly about 120 days to travel one way. These are true statements. 120 days. It's a long time.
Isn't that like the end of the season?
I guess. I don't know.
What?
Ask Miss Jankowski. Okay, what is the average rate at which a butterfly travels in miles per day? Even if you can calculate in your head. What formula are we using here? No, what formula?
Distance.
The distance formula, which is what?
D.
I forgot.
D
Divided.
equals
The
Time.
time
T and then D.
divided by
Time.
Time and distance.
The
V.
miles.
V.
Average
the
rate.
rate. Distance equals rate times time. It was on that initial formula list. If you don't know this formula, it's okay, right? You're not necessarily expected to memorize. But look at this. Science and math woven together. So here is our equation. Distance equals rate times time. You've already done this. Probably all of last year.
Yeah, it was last year.
Because how would you rewrite this equation? What are we trying to find? We're trying to find the rate. We were given the distance. Right back here, we were given the distance of 1,700 miles and we were given the time. So we're trying to find here the rate. So if I'm trying to find rate, how am I going to get that alone? Divide by time, because that R and T together, that's multiplication. If I have D equals RT and I divide by the time, look what I get. My rate is my distance divided by my time. Now, if I know my distance, which I do, it was 1,700 miles
When did it say that?
in the picture.
Oh, I didn't.
Sorry. And I divide by my time of 120 days. What's my rate? Now this is how you calculated a unit rate, right? If I told you I drove 150 miles in 3 hours, what was my rate in miles per hour? You would have just divided my distance divided by the time. That's what we're doing here. You can estimate, you don't have to give me an exact, about how much? It's probably about 15 or 14. Yeah, that's what most of the students earlier. So we can change that equal sign to a little squiggle. We'll say about 14. How can you know that without even calculating it? Think about how you could break down these numbers. So 120 times 10 is 1,200. And then how much do you have remaining there? 500. So how many times does 120 go into 500? 4. Yeah. And then there'd be a little bit left over. But yeah, it'd be about 14 point something. But yeah, that's how you can kind of estimate that number. Good. The last thing that we're going to do before we practice, I want you to just turn to the people around you. How are solving literal equations, which are the formulas and the equations with multiple variables, how is that similar to linear equations, and how is it different? Take about a minute. Find one similarity and one difference. Now, literal are like the formulas with multiple variables. Linear, like the ones we've been working with. Like that. How are they similar? How are they different? Solving a literal compared to solving a linear. What's one similarity and one difference? Try to come up with one at your table.
I know.
share one similarity that they came up with between a literal equation and a linear. They both use they both use variables. Think about the process of solving when you're talking. Is there anything else similar in solving them? Any other similarities you can think of between the two types of equations? These are the connections we want to try and make because you already, for the most part, feel pretty comfortable solving the equations that we've been working on so far this year and even in 7th grade. And I want you to see that these literal equations are not much different. The only difference, in my mind, are like those variables. But what about the process of solving? What else is similar? Think about what we do to solve one. Yeah, in both, you're still trying to get the variable alone. You're still isolating a variable. Absolutely. What are some differences? What are like the big, like when you saw these yesterday, when you saw them today, like what were the freak out differences? Like what did you notice today? What don't those equations have?
Numbers.
Some of them might not have numbers, right? That you may not be working with numbers, or I'll say integers, but I'll just say numbers in general, which can be kind of freaky, right? At this point, you're used to dividing by 2. You're not used to dividing by z, and it's kind of weird. That might be new. Yeah, you may not be working with numbers. My Venn diagram is totally not right here. But we're just going over differences and similarities. In a literal equation, you may not be working with numbers. In a linear, you are working with numbers. Any other big differences or similarities that you can think of?
I have one. Like with the linear equation, you can put that on a coordinate grid.
Okay, you can graph.
When I think of linear, I think of the thingy, like the slopes and all that. I don't like.
Yeah, we'll be going to that next year. Okay, yeah. What I hope you're taking from the process as we go through, especially here, focus on the similarities. Both equations use variables, but both are still isolating a variable. For so long, when you've learned to solve an equation, you've thought, I think, that solving is just getting the answer. For this, though, it's not really solving. Solving is isolating a variable. Up to this point, you've been getting a number when you solve, but now you're just going to get a rewritten equation, right? A literal equation written differently. So here is where we're going to transition to some practice, because I did tell you to have plenty of practice today. Okay, that page number's wrong. Okay, the first thing you are going to do, your must-do, are these 2 questions. You're going to do these in your binder. We are going to go over them with about 12 minutes left in class. Once you are done with the 2 must-do questions,
You have someone that's left the whole thing.
no, when we have 12 minutes left in class, okay. So you're going to do number 1 and number 2 first, keeping in mind that try to prioritize some time. Hey, let's see if we can do this in 3 minutes per question. Right, we're going to work on our time management. When you are done with that, you have 3 options. 3 options. You have 2 options in your textbook. This was actually what we were going to do yesterday, but we ran out of time. This was what we had planned on doing today. Or you could do the workbook. I'll put the updated page number because that was wrong. The reason I like the textbook, and you can do either one, if you are going to do the textbook, if you have questions, you can go back and see the examples that we went through today and yesterday. The first half of the lesson we did yesterday, the second half we did today. One quick thing I just want to point out when you're doing those practice problems. The first few problems have you solve for a variable and then substitute in. You are still rewriting the equations first. I'm not as concerned with you substituting the values in. You'll see like the equation and then a semicolon and then something like that. They want you to rewrite it and then afterwards substitute. I'm not as concerned with that. I want you to be able to rewrite the equations for a specific variable. If that confuses you in any way, if you're on page 112, go back to page 109, 108, I think, 110, because that's the questions we went over yesterday in class, and the questions that we went over today in class are all there, and everyth's broken out for you if you need to reference back to something. Does anyone have questions about your must do or your then do? Must do, then do. Okay, you have the entire class period, which means you have ample time to finish a complete assignment. Don't forget, if you finish a full assignment, you do get credit. We do have a point system. Our galactic hero, you will earn points, you will earn rewards for the assignment. That's an effort-based assignment challenge, right? So it doesn't matter if you're getting them all 100% correct. As long as I see that you're working towards the problems, you will get that credit. All you need to do for that is put them in the DOL bin when the assignment's complete. I can give you the credit for it. Don't forget that. Okay, it's just a way for you to get rewarded for doing more work and putting forth more effort in class.